Hello everyone, my name is Taylor Ellsworth and welcome to my talk, OAuth and End-to-End Testing, How to Ensure User Authentication Using Cypress. I wanted to give a quick thank you to Sauce Labs for having me here to talk to you all today, and I hope that everyone is enjoying SauceCon 2022. Before I dive into the presentation, I'd like to introduce myself. I am a senior software development engineer and test at Peloton. My primary responsibilities include architecting and implementing test automation solutions for both web and mobile applications, as well as setting up CI/CD pipelines. I am passionate about delivering high-quality applications and coming up with automated tools to help improve manual QA efforts. Outside of technology, my hobbies include traveling and finding pickup soccer games in New York City to join. So that's me in a nutshell. Let's begin. First, I'd like to give a quick overview of what we are going to discuss today. We'll start off with an explanation of what OAuth and Auth0 are. This section will be important since it will provide the necessary background information for the rest of my presentation. Next, we will learn why performing Cypress end-to-end tests for OAuth applications has its limitations. And finally, we will discuss how we can work around these limitations by implementing a programmatic solution that handles user authentication and bypasses the login page. This solution ultimately follows automation best practices and patterns, and it also increases testability and improves runtime performance. The first topic I would like to discuss is, what is OAuth? For those who are not familiar with it, OAuth is an open standard authorization protocol. It is the accepted industry standard mechanism used by the likes of Amazon, Google, Meta, Microsoft, and Twitter. It is designed to allow a client application access to a set of resources, like for example, backend servers, on behalf of a user without having to expose their credentials. In order to allow a client application access to a set of resources, OAuth uses something called access tokens. Access tokens are a piece of data that represents the authorization to access resources on behalf of the user. I know this explanation may still be confusing, so let me try to explain it in a more easy to understand way. Here, we have a very simple client-server application model. On the left, there is a client application that wants to grab some data from a resource server on the right. The client can communicate with the server to get the data using an API. The client makes a GET request to the server asking for data. The resource server responds to the request by returning the data to the client. Voila, easy enough, right? The client now has the data that it requested, so everything is good. However, not so fast. Some of you may be thinking that this doesn't seem secure, and you are absolutely correct. What if there is a malicious client application that is trying to get the data from the server? The malicious application can make the same GET request to the server, and the server will still return the data to the malicious client. As you can imagine, this is not good at all. As a result, we need a way to protect against the server data being returned to unauthorized clients, and this is where OAuth comes into play. With OAuth, an access token is given to the client before they make the request. This access token represents that the client application has been granted permission to access the resource server's data. When the client application makes a request to the server, it will include the access token in the request header. When the request is complete, the server extracts the access token from the request and verifies that the client is authorized and has permission to access the data. Once this confirmation is complete, the server responds to the client by returning the data. This is great. We now have a secure way to ensure that clients are authorized to access the server data. But now this raises the question, how does the client application get the access token to begin with? It magically doesn't appear. Remember, the client needs to obtain an access token before making any API request to the server. So how does the client get the access token? The answer to that is with an authorization server. The authorization server generates an access token and issues it to the client. So to summarize, the entire flow is as follows. The authorization server generates an access token and issues it to the client application. The client stores it in local storage or cookies. When the client application makes a request to the server, it attaches the access token in the request header. When the request is complete, the resource server extracts the access token and verifies that the client has permission to access the data. And finally, the server responds to the request by returning the data to the client. Now that we have gone over the entire flow, let's return to the first step where the authorization server generates an access token and issues it to the client. In reality, the client will first make a request to the authorization server asking for an access token. The authorization server responds by providing the access token to the client. Focusing even more on this step, when does the access token request and response happen? Remember, before making any request to the resource server, the client needs to obtain an access token. Because of this, the access token request and response happens when a user first logs into the application. And that's it. Hopefully this explanation made it much more clear on what OAuth is. The next thing I'd like to discuss is another term that I'll be using throughout the presentation, Auth0. Auth0 is a third-party authentication provider that implements the OAuth protocol we just discussed. Client apps can use Auth0's SDKs to assist with implementing the authentication and authorization logic. In simple terms, applications can use Auth0 to simplify their OAuth implementation. One very important note to point out is how a user logs in and obtains an access token with Auth0. When a user first navigates to a web application, they get redirected to login through Auth0's hosted login page. Once they enter valid credentials and successfully log in, they are redirected back to the original client with an access token. In the next slide, I'd like to show you a real-world example using the Peloton Members app. Let me first start off by navigating to the Peloton Members app. You will see that when I go to members.onepeloton.com, I'm ultimately redirected to Auth0's hosted login page. You can tell since the URL is now auth.onepeloton.com. Next, I will log in with my SauceCon demo account and press login. Here, I fetch the access token and get redirected back to the Members app. You will see that the URL is now back to members.onepeloton.com. Next, I want to show you that after I successfully logged in, the access token got stored in local storage. If I open up local storage, you'll see that the access token is here. And there it is. Now, as we discussed earlier, this token will be attached to the header of every API request to fetch remote data. When I attempt to view our strength on-demand classes and inspect the API call, you will see that the access token is ultimately attached as a request header. The resource server uses this access token to authorize the client user and return the correct data. Before we go any further, let's summarize what we have learned so far. We know that OAuth is an open standard authentication protocol that uses access tokens to represent if a user is authorized to access server data. When a user logs in, the client makes a request to an authorization server to get an access token. Once the client has the access token, it attaches the access token as part of API requests to the remote server. And when the request reaches the remote server, it verifies that the user has permission to access the data and returns the data back to the client. In addition, we learned that Auth0 is a third-party authentication provider that client apps can use to simplify their implementation of OAuth logic. When a user visits a web application, they get redirected to the login page hosted by Auth0. After a successful login, the user gets redirected back to the original application with an access token. Now that we all have an understanding of OAuth and Auth0, we can jump into the good stuff about how this relates to test automation. Let's say that we have a web application that has implemented OAuth with Auth0. Because we are all automated testing experts and quality advocates, the first thing we want to do is write end-to-end automated tests for this app. My personal favorite automated testing framework for web applications is Cypress. Cypress is a modern end-to-end testing framework for web test automation. Cypress is essentially a one-stop shop for all your end-to-end testing needs, combining a fast testing framework, graphical and headless test runners, and an easy-to-use assertion library in one package. Now, it is time to see if we can make an OAuth app and Cypress play nicely together. Let's write our first test. Imagine that we want to write a test to ensure that the user can visit a page that is only available behind authentication. Going back to our demo of OAuth, this means that we need to ensure that the user has an access token when visiting that page in order to pass it to the server. While thinking about how to automate this, we remember that a user gets an access token when they log into the app. As a result, the naive automation approach would be to log in the test user at the beginning of each test case in order to get an access token. The first step would be to visit our web application and wait to be redirected to the login page hosted by Auth0. Then, we would enter a valid username and password of our test user and submit the form to log in to get an access token. Finally, we would wait for the redirect back to our application. Now that we have an access token, we can visit any page behind authentication. We can now proceed with the test case verifications. Let's take a look at what this would look like in code. In the beginning of each test case, we would visit our application, which I call sauceconapp.com. Then we would need to wait to be redirected to the login page hosted by Auth0. Next, we would enter our username and password and press the login button. Then we would have to wait to be redirected back to our web application. Finally, we can proceed with visiting a page behind authentication. This seems easy enough and very straightforward, right? Unfortunately, there are problems with this solution. The first problem is a technical problem. One major limitation of Cypress is its inability to handle multiple top-level origins in a single test case. This makes it difficult to test applications that use third-party authentication providers, such as OAuth, since logging in a test user requires visiting a page that is hosted on a different domain. The second problem is a test automation best practice problem. The naive solution I described earlier is not a scalable solution. Requiring each test case to log in through the login page just to obtain an access token increases test runtime. In addition, it adds additional steps to each test case. These steps can introduce test flakiness and cause a decrease in test stability. Lucky for us, we have a solution which will solve all the problems I just stated. Instead of the naive approach, we will bypass visiting the third-party login page altogether by programmatically interacting with Auth0's Authentication API. This will allow us to get an access token and automatically have the user logged in at the beginning of each test case. To do this, we will use Cypress's request command to make an HTTP request to our authentication service, in this case it's Auth0, to get an access token. Then we will parse the token in the response to make sure it's in the correct format. And finally, we will save the token in local storage. Once the token is saved in local storage, we can now visit any page of our web application that is behind authentication directly, without having to go through the login page first. Now that we have a workable, scalable solution, let's dive into what the code for that looks like. The first step is to make an HTTP request to Auth0 directly to get an access token. This step mimics the logic that happens behind the scenes when a user logs in through the login page. We can use Cypress's built-in command cy.request to help us make HTTP requests. The request we will be making is a post request. The URL will contain the base URL of the Auth0 Authorization Server. For this demo, I am using auth.sauceconapp.com as the base URL. The specific endpoint that we would be hitting in order to obtain an access token is OAuth/token. At the bottom of the slide, I have included a link to the Auth0 API docs that give more details on this specific endpoint. Next, we need to include the following fields in the request body. The first two fields are the username and password of the test user. For grant type, we'll be using password since we are using username and password credentials to log in. Finally, client ID, client secret, audience, and scope will be taken from the application's Auth0 integration. The best practice is for these values to be stored as Cypress environment variables in order for them not to be exposed. As a result, we can access them with the cypress.env commands. So this is everything that we'll need in order to make a valid request to Auth0 directly to get an access token. The next step will be to use the .then method to access the response as a promise and parse the response in order to format the token in the correct response that our web application uses. As I just stated, we will now take the response from our request to Auth0 and parse it in order to programmatically format the token object in the correct format that our application uses. Once again, this process mimics the logic that Auth0 normally implements for us behind the scenes. The first step here is to deconstruct the response to pull out the values that we need. We will decode the response body's ID token and store it as a variable named claims. Then we will deconstruct the nickname, name, picture, updated at, email, email verified, sub, and expired values from the claims variable. In the following step, we will use these values to construct the token object, which we name Auth0 token, in the correct format that our client application will use. This consists of us creating a body object, which will use the spread operator to spread out all the values of the original response body. Next, we will create a decoded token object, which contains the claims value and the original Auth0 audience and client ID values. In addition, it will have a user object, which contains the user values of nickname, name, picture, updated at, email, email verified, and sub. And finally, the Auth0 token will contain an expires at field. Now that we have officially parsed the original response into the correct token format that our application needs, we will programmatically save the Auth0 token in local storage. Like I just stated, the final step in our solution is to store our Auth0 token in local storage. This is the line of code that does that. So there we have it. Originally, we had a very naive solution for ensuring user authentication and for running an automated test to verify that a user can visit a page that is only available behind authentication. The naive solution required us to log in through the login page at the beginning of each test case in order to get an access token. However, we learned that we should not use this solution because of two major problems. The first problem is due to the user being redirected to the login page hosted by Auth0. One major limitation of Cypress is its inability to handle multiple top-level origins in a single test case. The second problem is that this solution is not scalable. It increases runtime and does not follow automation best practices. As a result, we came up with a solution to programmatically make a request to Auth0 directly to get an access token, parse it, and ultimately store it in local storage ourselves. Now, we'll be able to visit any page that is behind authentication seamlessly in our test case and continue with our test verifications. I know this text is small, but I put the entire solution on this slide so it's in one place. I also have included the link to a GitHub repository on the bottom of the slide, which has the entire solution you can access. Going one final step further, the solution is great, but imagine having to write the previous code for every single test case. In order to follow don't repeat yourself principles, we can create a custom command to encapsulate the code and make it reusable across each test. Here, we create a custom command, login by Auth0 API. We call this command in the before each block to handle all of the logic for us before each test case begins. Then, we can go ahead and continue on with the rest of our test case logic, such as visiting the page that is located behind authentication. As you can see, this is much more readable and much more user-friendly. Now that we have our solution, I would like to demonstrate it in action with you all by using it in a real-world Cypress end-to-end test with the Peloton Members app. First, let me log in again with our SauceCon demo user. Let's pretend that the scenario that we would like to write an automated test for is that the user goes to the settings page and verifies that the Save Changes button is visible. Let me take a second to show you how we can get there and what the page looks like. One way is to go to the Preference page first and then press Settings in the navigation header. The other way is that we can visit the Preferences/Settings URL directly. If we scroll down a little bit, we can see that the Save Changes button that we would like to verify is visible is right there. And just a reminder, this page is behind authentication, so we will need to obtain an access token in order to successfully navigate to this page. On this slide, we have the test case code that uses our new solution. In the before each block, we will first programmatically get an access token from Auth0 by calling our login by Auth0 API command. Then, in the actual test case, we will visit the setting page directly and verify that the Save Changes button is visible without having to go through the login page first. Now, let's run the test using the Cypress open command so that we can see the results using Cypress's built-in GUI. It may take a few seconds to finish, so stay with me here. If we inspect the results, we will see that in the before each block, we logged the Auth0 token that we got from Auth0 directly. And if we look into local storage, we will see that we have successfully saved the token in the correct format there. And there we have it. Now that the Auth0 token is all set, we can verify that the rest of our test case passed. We are able to visit the setting page directly without having to go through the login page and successfully verify that the Save Changes button is visible. The passing steps and the test case result is evident by the green passing coloring. To wrap up, I'd quickly like to go over the final takeaways that we have learned today. First, we have learned about OAuth and Auth0 and what they are. Next, we learned why performing Cypress end-to-end tests for OAuth applications using Auth0 has its limitations. And finally, we learned how we can work around these limitations by implementing a programmatic solution to handle user authentication and bypass the login page. This solution ultimately follows automation best practices and patterns and increases testability and improves runtime performance. Hopefully, you can use this solution if you ever need to write end-to-end tests for an OAuth app. Thank you so much for joining my talk, OAuth and End-to-End Testing, How to Ensure User Authentication Using Cypress. Feel free to connect with me on LinkedIn or send me an email, and I'd be happy to answer any follow-up questions that you have. I hope everyone enjoys the rest of SauceCon 22. Thank you.